So proof by induction, be able to find the terms of a recursively defined sequence, big unions, big intersections, be able to deal with interval notation. And like I said, I was saying, I was concerned that people did as well as they did on that problem from special homework 10, where it was the interval problem, problem number 5. Too many people got that right. And even though I can't prove it, I have a feeling people were definitely using Google to find those solutions. That you're not helping yourself doing that. Oh well, you know.
Oh, which question was it?
Problem 5.
In homework 10?
Where it was interval notation, and I gave you, find the union of two intervals,
Mm-hmm.
the intersection of two intervals, the set difference of two intervals, and the set complement of an interval. People, just too many people got that right. It's just not. I've taught this class for 20 years, and I'm not certainly not saying you did that, Joshua. I'm just saying that too many people got that right, and
Oh, yeah,
that's
I
just
understand.
real easy to put into Google. That's not going to help you if you're using Google to get these answers. You're not going to be in good shape for the test. You got to understand that. You got to understand, cross products. And so then in chapter 7, all the function stuff, definition of a function. Can you construct a function? Do you understand arrow diagrams? Can you do the composition of two functions? Can you find the image of a set or the inverse image of a set? Um, whether that's a regular function or a composed function. Onto, of course, and one-to-one. So, it's actually not that long a test. I think there's only 7 questions. But they're multi-part, questions. Partition,
Actually, you mind going over 5C and 5D?
not at all. So I think I might have written those down. I might have written. Can you read 5C to me? Hang on, let me get some more paper.
Actually, hold on. I think it might be in the office hours from last week.
Yeah, but I wrote it down wrong.
Oh, yeah. Okay. Let me pull up 5C.
That was one of the ones I wrote down wrong. 5C, I think it was like
It was square
hmm,
bracket -3, comma,
5
5.21.
solve bracket or
Yes,
minus.
minus square bracket 1.24,
Uh-huh.
comma, 2.43 with the
Solve bracket.
parentheses. Yeah.
Yeah. Yeah, I wrote that one down wrong. So again, picture really helps. Positive 1.24. So positive 1.24 to 2.43. So the set is right there. So the complement is going to be these elements. It's not going to include 1.24 because it's in there, right? We have to subtract it away. And then we do include 2.43 because it's not here. So we're not subtracting it away to 5.21. So the answer was -3 to 1.24, solve bracket union, square bracket 2.43 to 5.21. Does that make sense? Because it was the difference of this set. So our elements have to be in here. All of these are in there, but we've taken away these. We've taken away the blue ones. Does that make sense? And the union is just an or. It means the x's that we want are either here or there. There's no way they could be in both sets because these sets are disjoint. Do I need to say more? I can. Joshua,
Oh, sorry, I was
are
muted.
you good?
Oh, yes, I'm good.
So
Sorry, I was muted.
what was D? Oh, you're just writing it down. So what
Yeah.
was D? Was it was the complement of this big set? Or was it
Uh,
like
it
-3
was
to
yeah, -3 to 5.21, and then
and then
complementary.
complement, right?
Yes.
All right, so here we're looking at the whole number line because the complement, it's like the reals minus
Mhm.
this.
And it's also, if I'm correct, it's everything outside of it
Right.
because the Venn diagram and stuff.
So we want the x's that are to the left of -3, but we don't include -3 because, it's included here.
Mhm.
And to the right and including 5.21 because it's not included here. So it is in the complement because it's not in the original set. Does that make sense?
Yes.
So it's what? -infinity to -3 inclusive union square bracket 5.23 21, excuse me, to infinity.
Okay. Yeah, I understand that. Thank you.
You're very welcome. Other questions?
Will a problem like this be on the test?
Absolutely. That's why I was so concerned when I saw so many people using Google to get that answer. But I just didn't have time to meet with like 20 students, online and call people out on it. It's going to catch up with you. That's what you were doing. Interval notation is really important. The most common error is people think that it's just these numbers, and people don't understand that there's lots and lots and lots and lots of numbers in here and in here. This is there are infinitely many numbers in here. There's infinitely many numbers in here. That's the main conceptual issue is people don't realize that these intervals represent real continuous intervals on the real line. There's infinite number of real numbers in here. We couldn't list them all. That's why we use interval notation. It's impossible to list them all. It's physically impossible. You can prove that you cannot list them all. Because it's an uncountably infinite set. These are uncountably infinite. They're not even countable like the integers. The integers are infinite, but they're countable. So you can at least indicate, the elements of the integers using lists with ... with ellipses, but you can't do that with the reals. Because these sets are just too big. Other questions? My suggestion is to definitely work through the worksheet on chapter 7 and the solutions are posted. Somebody asked me to post those today and I did. And there are, some explanations for those that, seemed more complicated, like the onto and one-to-one type questions that are a little more complicated. I wrote, fairly lengthy explanations of why the answers were what they were. But even still, these are fairly easy little problems because we're using finite domains and finite codomains. So you can always draw an arrow diagram.
Actually, Professor, I have an example, or sorry, I have a question about D, part D,
Of what number?
of the one we're just doing, of the
Oh,
-3.
sure.
So, for the,
Oh, wait a second. This should be.
yeah, yeah, that's what I was,
Good for you.
yeah, I was looking at, I was
Good.
like, shouldn't I, yeah,
Yeah, if that was a square bracket and it was, we don't want to include that because it's in this
right,
very nice Good job. You can email me for a couple of points.
Oh, okay.
Good job. Yeah, even the old Dr. Good can make a mistake at this hour. Hell,
All
I
right,
can make
thank
a
you.
mistake at any hour, apparently. That's okay. I got a big bank account full of extra credit points. Good for you. Good for you. I mean, but what are the things people get confused? Students confuse the definition of function with the definition of one-to-one. And that's really understandable because it's all about having double arrows. If you have an X in your domain X and you try to send X to two different values over here in Y, this is not a function. But it's okay to send X1 and X2 in the domain X to the same Y. That's not a problem. It's a function. But it's not one-to-one. See what I mean? That's why students get that confused. So if you can sort that, you'll be well on the way to not making the classic mistakes that students make as far as that is concerned. Does that make sense? You can't send one domain element to two different codomain elements, but you can send two domain elements to the same codomain element. That's not a problem. Any other questions? Last minute questions? Because we're getting up to close to 9 p.m. Here's your last chance if you have that burning question.
I have a question.
Hey, Sophie.
Right. This is this is one of the class notes due later problems from section 5.2, and it says
What day, do you know what day notes it was in?
this was day 18.
Okay. What does it say?
So the due later is 1 less than j less than n, and then it's the summation I equals to 1 to n, a of I minus another summation I equals to 1 to j, a of I, and then equals j plus 1, n is at the top, a of I.
So what I'm talking about there is this. Here's an example. If we have a function, a sum like, okay, here I'll give you one, like 1 plus 2 plus 3 plus dot, dot, dot. Let's just go up to like 499 plus 500 plus 501 plus dot, dot, dot plus 1,000. Let's say that's what we're looking at, right? But maybe we were only asked to find this sum from 500 to 1,000. Well, isn't this sum, which, where j plus 1 is 500, the same as the sum of all of them up to 1,000 minus the first 499 of them?
Yes.
That's all I'm saying.
Because I think you gave an example also. It
Yeah,
was
so 500 plus dot 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 plus 1,000 is equal to, well, add all 1,000 up, but then subtract the first 499. Yeah, okay, so what was the actual example that I gave?
621, 622 up until 6,000.
So 621, oh, plus 622 up to 6,000.
1,000, yes.
Well, my claim is that this is equal to the sum from 1 up to 6,000 minus the sum from 1 plus 2 up to plus the one right before this, which is 620.
Yeah.
So, right, so, this is n, 6,000 is n. The j is 620, and we're trying to find the sum from j plus 1 up to n.
Okay.
So the sum of I from I equals 621 to 1,000 is the sum from I equals 1 to 1,000,
1,000.
6,000, sorry, 6,000 of I minus the sum of the first 620. So from 1 to 620 of I. Yeah, this is a 6,000. It's just, we have to do a subtraction. If the sum doesn't start at 1, we have to use this subtraction trick because the formula only works if we start with I equals 1.
Right.
Does that help?
Yes.
Uh-huh.
Yeah,
Good. All right, folks, we are at 9 o'clock. Unless somebody has a burning question, it is time for us to call it a night. I'll stick around for a minute here in case somebody has a burning question.
I have like one more. It's not really a big question. It's this was on section, this is 5.1, and it is the factorial, and it's n plus 2 factorial over n, and then you ask us to simplify as far as possible. I just want to know if I'm doing the wrong thing.
Okay, so yeah, this was from 5.1. So it's n plus 1
N plus 2
factorial.
factorial over n factorial.
Oh, yeah. Yeah, you'll see these on the final.
Oh, not on test 3.
Out on test 3. This will be on the final, though. This is a good question for the final. So n plus 2 factorial is n plus 2 times the one right before, which is n plus 1, times the one right before, which is n, times the one before that, which is n minus 1, but that's n factorial, right? Like you just keep going down, 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 right?
Yeah.
Because if you look at a number line, here's n plus 1, here's n plus 2. N plus 2 factorial is this, times times n minus 1, times n minus, right? You just keep on going until you get down to 1, right? So you just expand the bigger one until you see the smaller one, right? And then you can cancel n factorial top and bottom because this is just a product. This is like if n is 10, it'd be like 10 times 9 times 8 times 7. Well, that's what you have down here. 10 times 9 times 8 times 7. Keep going, right?
Yeah.
And then these cancel and you're left with n plus 2 times n plus 1 on top.
Yeah.
So yeah, that's for the final exam for sure.
Okay. And if you have n minus 1 for the numerator, I know you have to keep going smaller, so
So if it's n plus 2 factorial over n minus 1 factorial, yeah, you would just keep expanding n plus 2 factorial until you see an n minus 1 factorial.
okay. I'm sorry to cut you off, but this question is n minus 1 factorial over n factorial.
Okay, well, on that one, the bigger number's on the bottom.
Yeah.
N is bigger than n minus 1. So you expand the bigger one. It happened to be on the bottom there.
Right. That's gonna be 1 over n.
Yep, exactly.
All right, thank you.
You're very welcome. And this one is n times n plus 1 times n plus 2. I'll just rearrange these three factors and put them in that order. Yep. Just expand the bigger one until you see the smaller one factorialized, and then you can cancel the factorial factor, and the rest is whatever's left over is what the answer is, whether it's on the top or on the bottom.
Okay. All right, thank you. Have a good night.
You too.
Thank you, Professor. Have a good night.
You
Have
too.
a good day.
You too. I'll see y'all soon.
Thank you. Have a good night.
Have a good night. Take care.